In this Algebra 1 video, Chapter 2, Lesson 1, we're going to talk about writing equations. Our objective is, as the student, I can translate between sentences and equations back and forth, no matter what, starting with one going to the other, because I will pay attention to detail. Also, I will be able to model situations algebraically. In other words, come up with some formulas that would match a situation, or vice versa. If you were given a formula, maybe write a situation that would kind of use it. Now, in these three examples on the left, we're going to translate each sentence into an equation, or in the case of example 1C, we're going to return it into a formula. So, what we'll do is this. For A and B, if you think you kind of already think you have an idea of how to do this, take a moment and just think about it yourself. Press pause and see if you can do it. And if you need to, even write it down so you can be honest and check yourself. Okay, so 10 times the number x is equal to 2.8 times the difference y minus z. So now what we're going to do here is this. It says 10 times a number x. So what that tells us we're going to take 10 and we're going to times it by a number x, meaning 10 times x. That's what that means. So that part is going to give us 10 times x. Now it says is equal to, so equal sign, 2.8 times the difference, so 2.8 times the difference y minus z. And in other words, we have to do the y minus z first before we can do the times, because notice it says times the difference. So we have to do that difference first. So this, if we're going to do it first, that might make you think grouping symbols. So that means y minus z. Oop, didn't mean to change pages on you. Y minus z. And now just simplify anything that you can. Not necessarily all the way with like the distributive property, but you could at least just do the 10 times x. So if you did that, you would have down here, we would have the equation is 10 times x equals 2.8 times y minus z. So 10x in other words. That's all I was saying. Alright, so let's take a look at the second one. It says a number minus 8 is the same as a number n divided by 2. Okay, so let's go from the beginning. A number m minus 8. In other words, they're saying m minus 8 is what they're saying. So a number m minus 8 is the same, or in other words, is the same, meaning equal, they're the same, is the same as a number n divided by 2. So in other words, n divided by 2. So you've got your equation now. Now all you need to do is essentially just kind of simplify it or translate it in a more simple way if you can. So take a look at this one. N minus 8 equals n divided by 2. But hey, n divided by 2 is also known as n over 2. So you can have that as well. So they're both kind of acceptable, but it might make it a little bit easier for a lot of people just leaving it as a fraction. Now take a look at this last one where we're going to turn into a formula. I'm aware that you already know this formula, most of you, but let's start off with an easy example so we can practice with that. It says the area of a rectangle equals the length times the width. Now translate the sentence into a formula. So here's what you do when you're turning things into formulas. Anything you don't know, any quantities, for example, we do not know the area, we do not know the length, and we do not know the width. Anytime there's something you don't know and you're going to write a formula to model it, that thing you don't know becomes a variable. Everything. So look for quantities that you don't know. So what we're going to do is we're going to say, all right, now sometimes they'll give you extra information, like they'll say, let certain variables represent certain variables. But if they don't, you can kind of make them up yourself. So A for area, L for length, and W for width. And again, if they didn't give you the letters, you're welcome to make up your own, but when you do that, you need to at least write a little legend what each letter stands for. Don't just make an assumption that's obvious. Okay, so if we do this, it says the area of it is equal to. So if the area of it is equal to, we said area is A, so area is equals the, so equal sign, length times the width. So we're going to have our length multiply it by our width. So in this situation, we defined what they were. We defined what each unknown was as a variable, and then we went and put them all together using the mathematical operation. And then we got the same answer of area equals length times width. So in these examples, we went from a sentence to an equation. Now we're going to do something, we're going to go in the opposite direction. We're going to go from an equation to a sentence. So let's say you had like example 2, A, B, C, D, and F. Now I'm not literally going to explain all of these. I'll help you with some of them. Then I'm going to have you try some others. So try some of them. Anyways, if we are given the equation, let's make sure we understand how to say it and translate what's going on in it. So let's look at example A, for example. If we said, you literally could say G plus 10 equals 3 times G. Now, or you could start to use more of your proper vocabulary and say the sum of G and 10 is 3 times G. So you can see these written both ways. So for example, example B. I'm not keep saying for example, example B. It's called example B. Anyways, we could say 4 times, because it's touching means times, 4 times, and now A plus B. Oh, think of another word for plus. Maybe sum we just said. So the sum of A and B. So we could say 4 times the sum of A and B is or equals 9 times A. So each of these kind of works out that way. That's what I'm saying. Translate some of these. So G plus 10 is 3 times G. And to save space, I didn't actually spell out the numbers. And the second one, 4 times the sum of A and B is the same as 9 times A. So now, give example C a shot on your own, and maybe even example D, and see how you did. Half of, because it's half times something, it means half of it. Half of the sum of f and y equals or is f minus 5. This one over here, you could say the sum of 2 times p and 4 times t. Or you can just say 2 times p plus 4 times t equals 20. So we can say the sum of 2 times p and 4 times t is 20. Now take a moment to think about E and F and hit pause if you need to, and then hit play and let's think about it. Now pause. Okay, for option E, you could say the difference of 8 and 6 times a number. So difference meaning you gotta subtract 8 and 6 times numbers. That's telling you it's the difference of 8 and that other thing, 6 times number x. So the difference of 8 and 6 times x is or equals the sum of 4 and 2 times x, or 2 times a number x. They mean the same thing. And then for option F, you could say the difference of k squared and n squared. So you could say the difference of squares k and n. That's kind of a fancy way of saying it. You're saying because they're both squared, so you're just referring to them as squares. But it's okay if that's a little too advanced. You can simply just say the difference of k squared and n squared equals 2 times b. And that would be yours for that one. Alright, so let's turn our attention down to example 4 at the bottom. The instructions for these types of problems will say something like, write a problem based on the given information. And here, we're given some algebraic relationships. We need to write a problem that would use them. That's what we're doing. So they gave us a legend. This is what you should be doing too. They said that C is equal to the cost per pound of plain coffee beans. They then told us that C plus 3 is equal to the cost per pound of flavored coffee beans. So I think that you can notice that flavored coffee beans, because it says C plus 3, they're going to cost more. And in fact, they're going to cost $3 more. So that's what we're doing in this question. We're going to find a way to describe it with, now actually write a story that we could have used these equations to model, to work with. So let's see, and then we're given the actual full formula, and then that's when we're going to use to kind of tell our story. So here's what we could say. We could say that, do it piece by piece, 2 times C. C represented the cost of plain coffee beans. So we have 2 times that. That means we bought it twice. So we could say we bought 2 pounds of plain coffee beans. That's what this first portion could be written as, we bought 2 pounds of plain coffee beans. And we bought, notice, and we bought, meaning we increased our price. So that could explain that plus sign. So you're increasing your cost. And we bought, let's see, C plus 3. Well, that's how much it was for 1 pound of flavored coffee beans. And notice there is no number in front of it right here. So we only bought one because technically there's a one right there if there's nothing there. So we would say, okay, 2 pounds of plain coffee beans, and we bought 1 pound of flavored coffee beans, and we spent $21. That's what we could say. And totaling $21 purchase. So then your job would be to now solve for, you could if you needed to. We just said write the problem, but then you could explain the problem you wrote could now say, now solve for the cost of plain coffee beans. So take a moment to write down what I just said to help you, and maybe your own slightly different interpretation, that's fine. So make sure you're sticking to the principles of what we just said. Okay, so brief recap, and we're all done. So we were talking about I can translate between sentences and equations back and forth. So in these examples, we had sentences and we were turning them into equations. And then we did the opposite order. We took some equations and translated them into sentences. And then at the bottom, we even went as far as taking a given equations or even some formulas, and we were then writing the story that could almost explain where these formulas came from using that information. So it was almost working backwards. So there's a little bit of a higher level of just simply having the story or the situation and then writing the formulas to model it. We were starting backwards. Sometimes that can help make those connections. But essentially, you'll notice we translated back and forth, and we also modeled some situations algebraically. In this case, we started with the algebraic and modeled a situation with it. So make sure you have neat, organized notes. Come to class prepared, and you'll take it to the next level. Good luck, guys.